Hello, this is Taskmaster, an autonomous work console built for people who want work completed in the background without losing visibility or control. The problem is familiar. Chat tools can answer a question, but a useful agent has to plan work, execute it across multiple steps, keep a durable record, recover when something interrupts it, and hand the operator a result they can inspect. Taskmaster makes that entire path visible. The operator begins in mission control. A task is written in normal language. For example, research 3 public Australian co-working spaces, compare their locations and differentiators, and create a Markdown brief. The request does not go straight into an unbounded model loop. Taskmaster first creates a persisted task record and a background run. That gives the operator a stable task identifier, a visible status, and a place where every action will be recorded. Gemini 3.5 turns the request into a bounded execution plan. The planner can select only tools registered by the application. In this example, it uses public web research, structured extraction, and file generation. Each plan step is stored before execution. The interface exposes the plan, its tool inputs, the rationale, and the result of each step. That means the agent is not a black box. The operator can see what is about to happen and what actually happened. The runner executes those approved steps asynchronously. It persists step status, tool calls, summaries, errors, and generated file metadata. If an external model request times out or returns incomplete plan JSON, Taskmaster records a recoverable failure rather than leaving a task silently stuck. The planner has explicit limits and an executable fallback plan. Those guardrails were added because background work has to be dependable, not merely impressive when everything goes perfectly. Recovery is a first-class workflow. During the live Cloud Run acceptance test, Taskmaster created a task, persisted its plan, was cancelled while active, and then resumed. It reused completed work instead of starting from nothing or duplicating every operation. The same acceptance run completed its research, created a final summary, generated a Markdown deliverable, and verified that the file could be downloaded successfully. The result is a durable trail from the operator's request to the finished handoff. This architecture view shows the boundaries that make that behavior possible. React and TypeScript provide the mission control interface. An Express and tRPC control plane owns task creation and lifecycle changes. The stateful runner coordinates persisted planes and steps. Gemini is the planning engine. The execution log is the source of truth for task and run state. Finally, the constrained tool layer exposes public research, extraction, email drafting or approved sending, and file creation. Each layer is intentionally separate, so a failure can be inspected and recovery can be precise. The typed API reference documents the same public task surface used by the dashboard. Create a mission, rest work, inspect a task, cancel it, or resume it. This keeps the product testable and makes the lifecycle explicit instead of burying it behind a single chat interaction. The backend is running on Google Cloud Run. In production, Taskmaster uses the Google Gen AI SDK with a Vertex AI path and the Cloud Run service identity, so no model API key is baked into the deployed container. Generated deliverables are written to Google Cloud Storage and are served through a validated Cloud Run download route. The live hosted application, completed acceptance run, public source repository, architecture diagram, and reproducible setup instructions are all included in the submission materials. Taskmaster is built around one promise: